So I'm Rick Rys. I'm an analyst at ARC, and so I will be moderating this session. We have 4 speakers and also 3 panelists. So I will give a short presentation, and then each of these 4 speakers will give a presentation, and with available time at the end, we can open that up for a discussion. So I'm going to start off the session with a brief, let me see, we got the clicker here too, right? So a brief story. You know, my background came from industrial process control. I did a lot of work in refineries. I did advanced process control. I did PID, ladder logic, sequential control. We did all of this kind of control functions in refinery. We also did optimization. But in the last 5 years, I've switched over from all of that know-how and expertise and decided, you know, I like a new problem. So how are you going to control the electric grid? Right? And they're really very similar in some ways, because in the process industries, you're controlling the flow rates of molecules. In the case of the electric grid, you're controlling the quantities and technically the flow rate of electrons as well. And you know, if you wanted to increase the pressure in a liquid things, it goes pretty quickly. You know, to increase the pressure of a gas, it will increase the number of molecules stored in a vessel. If you want to, you can technically store electricity by a capacitor or supercapacitor by just accumulating electrons, but it's a little bit harder to accumulate them and move them around, and they move a little faster. All right? But nevertheless, the problems are very similar. You know, on the electric grid, we see all the control problems are the frequency control of the grid. All right? They have optimization that is computing the LMP price every 10 minutes with a linear program that is hoping to adjust supply and demand and keep it balanced. All right? So all of these control functions are a big problem. In fact, I think as you said in the introduction, the electric grid is the largest system integration problem of our time. It is a very big problem, very difficult to control, and a lot of issues associated with the future of that grid. All right? All right, can we advance a slide? It says I'm on. All right. So the first interesting problem is less than 1 billion people are left without electric power, right? Within the last 10 years, we've seen enormous progress in both China and India, that basically both of these countries now are claiming 100% electrification. But there's a little bit of difference. In China, there is massive high voltage DC, and there is a very strong electric grid. They are now generating more power than we generate here in the US. That wasn't true 10 years ago. In India, it's a little bit different. They have got power to 100% of their population, but some places only get it for 5 hours a day. All right. So the remaining part of the world that it's not electrified is in Africa. All right. But still, that is very quickly happening. And what you're seeing is things like nanogrids popping up. And at first, it's just, oh, I just need enough power with a small solar panel and an old junk car battery to charge my phone. And then pretty quickly, well, I want some lights at night. And then I want a refrigerator. And then I want they want to be like Americans are. All right. And there's a large part of the population that even is electrified today. You see it in Latin America, but you see it throughout Asia as well, that want to have the electrical standard of living that we have and the economy that goes with that electrification. All right. So the problem, though, is that we have today is that with all of this great standard of living, we don't just have a problem. The electric grid is so highly disruptive because the electric grid has to change first to solve this CO2 problem. Right? You can see with this graph the total amount of energy used. This includes energy for transportation, energy for building heat, and of all types, as well as energy that is used for electric generation. And you can see that, wow, we are really dependent on coal, crude oil, natural gas, you know, but then there's all these other energy sources as well. And renewables are kind of a small percentage of that. So the problem is that, well, how are we going to get rid of all of this carbon formation? And the basic idea that utilities have is, well, we have to first of all make the electric grid carbon free. And then the second longer term problem is to make all transportation, building energy, or not all of them, or substantially carbon free. And so that's why the electric grid is being prompted, you know, being forced to be kind of the first part to change. It'll take time to make electric cars and electric, you know, mini split heat pumps and or ground source heat pumps, et cetera. Next. So these are electric grids worldwide. In the U.S., we have 3 different electric grids, essentially, Eastern, Western, and Texas. Each one is running at its own frequency. They're all pretty close to 60 cycles, though, because if you get too far from 60, the grid shuts down. But you can see Europe has a big and strong grid. And so these grids are not, some of them are not interconnected. European is largely connected. I guess with Brexit now, the Brits don't, they had their own grid anyway. Right, next. So in China, we see they've become masters of high voltage DC transmission. They have a most sophisticated know-how for high voltage DC. They have million volt systems. Siemens, ABB came in there, trained them how to do a lot of these things. And then you see, they also have great ambitions to electrify most of Asia, and expand their electric grid. You're talking about state grid. They have 1 billion customers and 1 million employees. This is a big outfit. They're just big. Then you see Japan. Japan has 2 grids. Half of Japan is 50 cycles. The other half is 60. Okay, the next. In fact, the top guy there at State Grid suggested that, and wasn't he the first to make this suggestion, that eventually we will have a single grid worldwide. Now, this is definitely long term. So we did talk about the future. So this is not going to happen in my lifetime. But in principle, it's sunshine on one part of the world could be delivered to the other side. But that would take, we certainly don't have the technology to do that. We don't have superconductors. We still have lines that can't do this. And the best of high voltage DC, will fail today. But eventually, that's the way to go. So let's take a look at kind of the problem again. And these kind of show all of the different energy sources that we have. And Lawrence Livermore makes these every year. I haven't got the latest for 2019. It might be out by now. But what they're showing is of all the energy that we consume, where does it go? And you can see in the middle toward the right side that there's residential, commercial, industrial, and transportation. And you can see which energy sources are used by which resources. Now, obviously, if you're going to electrify a lot of these, or maybe will be carbon capture technologies that could be used for some of the hydrocarbon fuel sources, then you have a kind of a problem that if you wanted to make renewables, you look at how teeny that wind and solar are today. If you were trying to make a lot of people have this grandiose idea that we're going to make 100% renewables and we'll get that done by 2050. But you couldn't expand wind and solar fast enough in that time frame. I mean, you would have to bid 100 times what we have installed today, and then of course you would have the storage problem as well. And we'll dwell on all of these next slide. So in any event, the question is, what is our future power mix? And there's all kinds of different people that make projections, and you can see we still have a lot of coal. We kind of know that coal will be in decline. China and India electrified their countries to a large extent quickly by using coal, which was a cheap and fast way to electrify, which is kind of what the U.S. did way back when. But I think that you'll definitely be seeing coal in decline. The question is, what is the future? Next. So in any event, I'm only going to leave you with one idea. One of the things you like to have is the digital twin, a model. There's a couple of simulators around, but I encourage you to try this simulator from En-ROADS. It's an MIT initiative, and they give you all of these different dials. You want to change the planet, you can change it here. You can simulate all of these different options in the planet. You just move these little sliders left and right, and you can decide which things. Now, obviously, this is the intertwined problem of regulations, political will, technology. There's no shortage of tremendous difficulties and options here, but there are certainly a lot of options, and this is why we see a disruptive grid. So next presentation, we're going to start with Nicole.